Assalamualaikum. My name is Muhammad Ahmad Alif bin Mat Haris.
My name is Muhammad Ahmad bin Muhammad Saifuliza.
My name is Muhammad Shamin Nashri.
I'm Shalini Singaravelan. Today we are going to present about Analog Electronics assignment. Our title is based on BJT Common Emitter Unbypassed Bias. Common amplifier configuration for an NPN transistor, which is common emitter amplifier circuit. Common emitter amplifier circuit has a resistor in collector circuit where the current will flow through the resistor and produces the voltage output of the amplifier. The main objective of our assignment is to build a common emitter unbypassed bias circuit with -4 AV gain. Let's see how we achieve our objective.
Hi guys, so today I will explain about common emitter amplifier. I hope you all enjoy my explanation. So first, let's see what is our task. Our task is for construct a CE unbypassed bias. What it mean for CE unbypassed bias? In common emitter amplifier, we have two types. One is unbypassed bias amplifier, and second is bypass bias amplifier. The difference between these two types of common emitter amplifier is, in bypass bias amplifier, we have capacitor that parallel with resistor emitter. That means the current will not flow to resistor emitter, but it will flow to capacitor emitter. But for unbypassed bias amplifier, no capacitor parallel with resistor emitter, so the current will flow to resistor emitter. So in this task, we need to construct a CE unbypassed bias. Therefore, we use the figure 1.1 as our circuit. Okay, let's see for our next task. We need to make a gain -4. What this mean? That means we need to choose either we need to use PNP transistor or NPN transistor. As we know, BJT, we have two types of transistor, PNP and NPN. For PNP, the gain never be negative because no frequency phase shift. But for NPN, the gain will be negative because frequency output will be phase shift 180 degrees from frequency input. Therefore, we use NPN type of transistor BJT because the AV gain that we want is negative value. Our next task is need to find frequency Fs for 78 Hz, Fc 320 Hz, and it gives the value for capacitor CVE, CVC, CCE, CWI, and CWO. So these all we will use in frequency response analysis. That means we need to make a both plot to find our lower frequency and high frequency. Okay, let's go to our main point. How we want to design CE unbypassed bias with AV -4. So we need to do 3 steps. One is direct current DC analysis, alternative current SC analysis, and frequency response. In direct current DC analysis, we need to determine IC, IB, and IE. But how? Oh yes, we can use datasheet. Therefore, we use 2N4401 NPN transistor as our main component, and we use 2N4401 datasheet to find reference for characteristic for this transistor. Alright, let's watch this figure. In this figure, it shows when IC 1 milliampere and VCE 1 volt, we can choose the beta from 40 to 300. Therefore, we determine our beta is 60. Okay, now we already have beta and value of IC and VCE. Now we can find IB and IE because IC, IB and IE current is relationship between each other and value of beta. Okay, now how to do DC analysis? For DC analysis, we need to do two things first. First, split VCC, and second, capacitor we need to open. And then we get these two loops, base emitter loop and collector emitter loop. Okay, let's analyze base emitter loop first. If we take the value from the ground and make a loop just like an arrow at the picture, we can get the equation negative VCC plus IBRB plus VBE and IERE. From datasheet, we get the VBE is 0.75. Therefore, we already know our IE and our IB. So, we use mathematical equation to find one of these resistors. So, I find RB first. Same like collector emitter loop, if we use to find equation using the flow of the arrow, just like at the picture, we can get the equation 2. Alright, let's move on to AC analysis. In AC analysis, we need to make VCC ground and capacitor need to short. Therefore, the current will flow to capacitor. Okay, this picture show the AC analysis with inside of transistor model. Inside of transistor model, we have beta RE and beta IB. For RE formula, we use 26 milli divided by IE. Okay, now let's find our Vin. As we can see at the left side, RS is parallel with RB, RB is parallel with beta RE, series with RE. Therefore, the voltage between each resistor is same. At beta RE, we know that current IB flow. Because the beta value is bigger than 1, therefore, we can get this equation 3. Okay, let's find our V out. As we can see at the right side, the RC and RL resistor is parallel between each other and parallel with current beta IB. And by using Ohm's law, we can get our V out as equation 4. Now we know that gain AV is V out divided by V in. Therefore, we use equation 3 and 4 to find our AV. By using equation 2, the value of AV that we get from the equation, and we determine the value of RL, put together with formula for AV, we can find the value for resistor collector RC. You can see we have two value of RC, but resistor never been negative, so we use RC equal to 7 kilo ohm. After we get value for RC, we can get value for RE by using equation 2. And after we get value of RE, we use equation 1 to get value for RB. Okay, now we can draw our full circuit. Oh wait, we have RS. For RS, we can determine anything value. But we need to make sure that it not to influence much at frequency response later. Okay, how about we do CE amplifier simulation first to know that our circuit is success or not. By connect oscilloscope probe into V in and V out, we can find our frequency. Now we can see frequency from the oscilloscope. As we can see, the red frequency is V out, while the yellow frequency is V in. The red frequency is 180 degree phase shift from the yellow frequency. Okay, now let's see our V peak. If we divide our V out by V in, we can get negative 3.21 AV gain. So it's not too much different from negative 4 dB gain. So we can say that our circuit is success. Okay, that's all for DC and AC analysis. What we want to do next is frequency response. So let's go to my friend to explain more about frequency response.
What is the frequency response? Frequency response is an electric or electronic circuit allow us to see exactly how the output gain, known as the magnitude response, and the phase, known as the phase response, change at the particular single frequency, or over a whole range of different frequency from 0 Hz DC to many thousands of megahertz, depending upon the design characteristic of the circuit. There are two types frequency response, which is low frequency and high frequency. We only use two low frequency. Frequency that we use is FLS, which is low frequency supply, and FLC, low frequency collector. We don't use FLE because there are no capacitor at the emitter. For the high frequency, we have FHI, which is high input frequency, and FHO, high output frequency, and the frequency beta, which is frequency at the beta. This is the example for the board plot graph for the low frequency and high frequency. In our circuit, FLS and FLC is provided, and we assume RS equal to 1K. Then we need to find the CC, which is capacitor coupling, and CS, which is capacitor at the source. To find the CS, we use the FLS formula, which is 1 over 2 pi times RS plus RC times CS. And for the CC, we use the FLC formula, which is 1 over 2 pi RO plus RL times CC. Then we need to find the FHI, which is equal 1 over 2 pi times RTH times CI. For the RTH, we parallel RI parallel with RB parallel with RS. And for the RI, which is beta RE plus R3. For the CI, we take CWI plus CBE plus 1 minus AV times CBC. AV we get from the AC analysis. For the FHO, which is frequency high output, the formula is 1 over 2 pi RTHO times CO. For the RTHO, RC parallel with RL. For the CO, CWO plus CCE plus 1 minus 1 over AV times CVC. For the F beta, the formula is 1 over 2 pi beta mid RE times with CBE plus CBC. This is how we get the CS. We use the formula CS 1 over 2 pi RS plus RI times CS. So for the RI, R beta parallel with beta RE plus RE. After that, we change the place FLS and CS. Then we can get the CS. For the CC, we use the FLC formula, which is 1 over 2 pi RO plus RL times CC. After that, we can get the CC, coupling capacitor. This is how we get for the FHI, frequency high input. The formula is 1 over 2 pi RTHI times CI. The FHO, which is frequency high output, the formula is 1 over 2 pi RTHO times CO. And the RTHO, which is RC parallel with RL. After you get that, you must find the CO. CO is CWO plus CCE plus 1 minus 1 over AV times CBC. After that, you can get the FHO. For the frequency beta, the formula is 1 over 2 pi beta mid RE times CBE plus CBC. So our beta is 2.7296 MHz. After we get all the value, we put it into the circuit, then we run the simulation to get the board plot graph. This is our board plot simulation. And this is our sketching for the board plot graph.
Okay, for the conclusion, it can be said that this task is successful because from the theoretical value, the actual value or the value that we calculate, and the simulation value almost the same with a small absolute error. Okay, this is the data that we get. You can see the data, the theoretical value and the simulation value is almost the same. For the voltage in and voltage out, also the same. There is no many difference. This is the final circuit that we get, the common emitter amplifier circuit with the voltage gain of -4. This is the frequency from the oscilloscope. The yellow frequency is the input frequency and the red frequency is the output frequency.
Okay guys, that's all for our video presentation. Thank you for watching.